Yeah. Good evening, children. Good evening, Harsha.
Good evening.
Good evening. Yeah, I think we start with this one in the last class, right? Yeah, we finished lesson 2. We finished all the subdivisions in question number 2. And this one, I did not send the message on WhatsApp, but I did mention in the class that you should be completing these two as homework. If you have not done, I'm just showing you the answer. Go through and complete it, please. Please work this one. If you have not finished this as homework, please work it now. So here also, first take a look at the coefficients. The coefficients are 10, 2, 6, 5, 1, and 3. Can you see? 10, 2, 6, 5, 1, and 3. All right. So you should, like try to find some relation between these coefficients. Some relation between these coefficients. So you can see here, 1 ones are 1. See, like 1 ones are 1, 1 twos are 2, 3 ones are 3 ones are 3 twos are 5 ones are 5 twos are. See here, 1 and 2, 3 and 6, 5 and 10. 1 into 1 is 1, 1 into 2 is 2. This is in the tables of 1, children. This is in the tables of 3. This in the tables of 5. 1 into 1, 1 into 2. 3 into 1, 3 into 2. 5 into 1, 5 into 2. All right. So we group it using this idea. We try. We'll see if it works. Otherwise, we'll have to change the grouping pattern. All right. So always take the help of the coefficients to get some idea as to how to arrange or group the terms. Okay, so you can see here, I've written this one first, coefficient 1, and this one, coefficient 2. The numerical coefficient I'm talking about. Numerical coefficient I'm talking about. And then coefficient 3, coefficient 6. Then 5 and 10. 5 and 10. All right? Yeah. So group these two terms, and these two terms. The rest, you'll have to take out the HCF, take out the HCF, and you see that in the brackets, you get the same expression everywhere. Everywhere in the bracket, you get the same expression. So then write this once and gather all this and put them in another bracket. Yeah, please do it. Yeah, Tanya and Ovi, if you have any question, please come here. Yeah. finished? Both? Both? Yeah. Navneet, don't do by yourself. Now work on it, Kempar. You should refer that book. In the second one, I have not rearranged. I just thought, let me try. All these have m square, in fact, and all these have p in them. Q in them. These three. Simply trying. See, there is no trick or clue. It is something like the trial and error method. You group in a particular way, and how do you make out that it's not working? If you have different expressions in the bracket, that means you have to try another way. If your grouping is correct, then you will get the same expression in the brackets. You can get anything outside here and here, but the expressions in the brackets must be the same. If they're not the same, then you have to change. Meaning you should rearrange the terms and group it in a different way. Yeah. So here simply tried like this. All this has m squared, and this one q. All these three have q in them. Q squared, and this one is q cube. So simply tried, it worked, and so that's fine. Okay. So talking about these three terms, m square, m square, m square. So m square is a HCF. Then n square, least power, right? So n. And then nothing else is common between all the three terms, right? Because this one has only m and n. So m square n is common. Yes or no, Surya? Yeah. So now m square n into what will give you this first term? M square n into what will give you the first term? M square n PQ. So PQ. Next, m square n into what will give you the second term? M square n p square. M square n is out here. So p square. Yeah. Then m square n into what will give you the third term? Minus m square n square. Yeah. See, you should take a look at the sign also. So the outside the common factor is m square n into what in the bracket will give you minus m square n square. So minus, there's n square here, but only n here. So minus n. Now between these three, q square is common. Q square is common between these three. So q square into what will give you this term? PQ cubed. PQ. Similarly, q square into what will give you this term? P square q square. P square. Meaning plus p square. Now q square, if the sign here is minus, then it will be minus q square. Okay, so q square into what will give you this term? Minus q square n. Minus n. So now you see that the expression in both the brackets is the same. In both the brackets, we have the same expression. So write that once. This one. And then gather these terms. m square n plus q square in another bracket. You can write anything first. You can write this one first and then this. Order is not important. It's a product, right? So anything first. Here we understand?
Excuse me, ma'am.
Yeah.
I joined through my phone because my computer had an issue.
Oh.
I joined right now, ma'am. Should I copy this down?
I'll just clear the screen. Take a screenshot, Aishwarya.
Okay, ma'am.
Yeah, please complete it later. Yeah.
Well, this is all you've done, right?
Yeah, yeah.
Okay.
Yes.
Yeah, taken.
Yeah. So here, children, again, HCF. What's your HCF? S and S cube. So S T square, T square, T square, V and V to the power 4. So V S T square V S T square V. And you understand how to get these terms. And then here, the HCF of 3 and 6 is 3 S square and V cubed. 3, only 3. And between the last two terms, 5 and 10, 5. HCF is 5. S to the power 4, S square. Least power, S square. No. So 5S square. Right? And then you see the expression in all the brackets is the same. S square plus 2V cube. Same thing here, same thing here. So that means we have grouped it correctly. We have the same expression in all the three brackets. So write that once. This one, which is the same in all the three brackets, write it out once. And then gather these terms and put them in another bracket. The reason is, children, see, it's like this. Just treat this as, see, these are different, no? This is like A, this is different. So like plus B and plus C. 1 minute. See, this is like A, and I'll write this plus 3 as plus B, and this one as plus C. Okay, in the bracket, we have the same expression, right? So let me call it D everywhere. A into D plus B into D plus C into D. You understand what I'm writing? In the bracket, we have the same expression. So let's call that D. Let's call that D. That expression in the bracket, we'll call it D, all right? So, but outside we have different terms outside. So we've called them A, B, C. So what we have is like AD plus BD plus CD. Now what's common here? D is common, right? D is common. So then in the bracket, what will you write? A plus B plus C. That's what we've done here. This is common. This is common. So we write it out once. What did you do? See, D is common. So you put D outside and then A plus B plus C, right? In the bracket. Yeah, that's what it is. This is common. So we write it out once and then we put all this in another bracket. Finish writing. Yeah. Yeah. Do this. Try. I have the answers ready. We'll see the answers. Okay. Harsha, Saujanya, and Aishwarya, please try all these questions.
Yes,
We'll discuss the answers. Yeah, we'll discuss the answers. Yeah, let's see the answer for 1A and B. So 1A, true or false? True. 1A is true. False, huh? Gayatri? 1A, true or false? True. True. You say false. You also say false. Online students? 1A, true or false?
True.
How many of you truly feel it's true? Yeah, tell me. Harsha?
I feel it's true.
Okay, Saujanya, Aishwarya, Yarni? Okay, playing safe. You don't want to try and go wrong, is it? Okay, the correct answer is false. It's false. Because you can factorize it further. What is the HCF of 15P and 15PQ square? What is the HCF? 15P. 15P. The HCF of 15P and 15PQ square is 15P. I think you got it right? Yeah, it's okay, Gayatri. Got it now? Yeah. 15P, right? Yeah. So then in the bracket we have 1 minus Q square. That's all? That's all? No, this can be factorized further. Because 1 minus Q square is of the form A square minus B square, which can be written as A plus B into A minus B. So 1 is 1 square. A square minus B square. So 15P, A square minus B square is A plus B. What is A plus B? 1 plus Q into 1 minus Q. Yeah. So the first one is false. Cannot be factorized. Cannot be further factorized. False. It can be further factorized. What about the second one? The factors of 9AB minus 18A square B are 2. Yeah, let's understand this. Now 15. 15 can be written as 3 into 5, right? So the factors of 15 are 3 and 5. The factors of 15 are 3 and 5 because 15 can be expressed as a product of 3 and 5. So these are the factors, the prime factors of 15. In the same way, this expression 9AB minus 18A square B can be written as, what's the HCF of these two? 9A. This is the HCF, right? So B, B is also there, sorry. 9AB. Because there's 9 and 18 is 9. A square. A, B. Correct? 9AB. 9AB into 1 is 9AB minus 9 2s are 18 and A. So this expression can be written as 9AB into 1 minus 2A. 9AB into 1 minus 2A. So these are the factors of this expression. Like 15 can be written as 3 into 5, where we say 3 and 5 are the factors of 15. In the same way, 9AB and 1 minus 2A are the factors of this expression. 9AB and 1 minus 2a are the factors of this expression. In fact, the factors are 9a, b, and 1 minus 2a. And 9 can be further written as 3 into 3. So all these are the factors of this expression. True. This one is true because they've taken out the HCF correctly. 9ab is the HCF. Yeah, I think you have not factorized further, so please take down this working. If it's false, you need to do it correctly. Yeah, Obi, you can come here. You have a question, right? Oh, no. Okay. Hmm. Now, what are you going to do ahead? Oh, okay. Finished? Yeah. I'll come back to the questions. Please continue. Okay, Shivam, tell me. 48 a squared b minus 12 ab squared plus 12a minus 3. Let's try grouping these two and these two. Let's try. It should work because see, this is 12 ones are 12, 12 fours are 48, and 3 ones are 3, 3 fours are 12. Let's see. So it should, you understand this is 3 and this is 12, no? 3 ones are 3, 3 fours are 12. And this is 12 ones are 12, 12 4 times 48. So it should work. Let's see. So what's the HCF of these two terms? 48 and 12. What's the HCF? 12. Okay. Then a square and a. Least power. A. B and b square. B. Open a bracket. Now this into what will give you 48 a square b? 4. There's a b outside, no? Louder. 48. Oh, sorry. 48a square b square, is it? Okay, I'm sorry. Thank you. 48a square b square. So then 12a b square will be common. Right. Okay. So it will be 4. 12 4s are 48. A into a is a square and b square is already there. Minus 1. 12 ones are 12. So leave that. Now ab square, ab square. We have it here already outside. So minus 1. Now what's the HCF of these two? 3. Now whatever sign is here, after the second term, whatever sign you see here, plus put that 1, open a bracket. Not 1, sorry, 3. 3, open a bracket. 3 into what is 12? 3 4s are 12. A. Then plus 3 into what is minus 3? Minus 1. So 4a minus 1 and 12ab square plus 3. But can you see here that there is 3 common between 12 and 3? There is 3 common, right? There's 3 common. So 4a minus 1. There's 3 common here. 4ab square plus 1. 3 is common. I've taken out 3 common. No, don't write. I have to say something else. So 3 4s. Understand? 3 is common. Right? Whenever there's something common, you should bring out the common factor. So 3 4s are 12. So 4ab square plus 1. So now what do you understand? In the expression, when there is something common, see, when all the terms have something in common, in 2a, this expression has 4 terms. It has 4 terms. Is there anything common between all the 4 terms? 3. Yeah, whenever all the terms of the expression have something in common, first bring out that common factor and then group. You can do it in 2 ways. I have the answer in both the ways. I'll show you the answer now. Listen to this. So in the expression, now this expression has 4 terms. Now in this expression of 4 terms, if there is something common between all the terms, so 3 is common to all the 4 terms, right? So take out that common factor first. I think I have it both the ways. Oh, I don't have it. Okay, I'll do it. So see here, since there is 3 common, 48, 12, 12, 3, multiples of 3, right? So take out 3 common. So then you have these terms in the bracket after taking out 3 common. Now group the first 2 terms and the last 2 terms. That's all. The first 2 terms and the last 2 terms. All right. You can also do it like this. But this is preferred meaning, you know, it's better you have a particular, a discipline in working. So in the expression of all the terms have something in common, take out the common factor. That's the golden rule actually in factorization. You understand? Yeah, that's the golden rule. So always start with that. Get used to that. Even if you don't take it out, you can still factorize correctly. Okay, see here. I'll just do that here. See here. Supposing you straight away group the first 2 terms and the last 2 terms, it'll be 12ab squared in the bracket 4a minus what is that? 12ab squared. So 1. Then plus 3 4a minus 1. So it is 12ab squared plus 3 into 4a minus 1. I've purposely written 12ab squared plus 3 because there is 3 common, no? So I've purposely written that first. Now take out that 3 which is common. 3 is common. So 3 4s are 12. ab squared plus 1 into 4a minus 1. You can work it like this also. Both are correct. Both are fine. But we'll, like get used to working like this. That is, whenever there is something common, when all the terms of the expression have something in common, take out the common factor. Let that be the first rule and the golden rule. Yeah. You can also do it like this. So take it on both the ways. So this is one method. What you see here, this is one method. This is the other one. This is preferred. The second one is preferred. And I think, sorry, you must have stopped here, no? Children, you must have stopped here actually, right? Yeah, you should go ahead. You should. Between 12 and 3, there's 3 common. Did you do this step? No, yeah, that's what it is. So if you stop here also, it's not factorized completely. I'll tell you what that means, okay? It means this. See here. Can I have your attention? It means this, you know, like say, okay, so say we have 30. 30, I write it as 5 into 6. It's not completely factorized. If I write 30 as 5 into 6, I haven't factorized it completely because 30 is equal to 5 into 6 is further 2 into 3. 6 is further 2 into 3. Right? In the same way, this expression can be further factorized as 3 into 4ab squared plus 1. Like 6 can be further written as 2 into 3. 5 is 5. But 6 can be, in this example, 6 can be further written as 2 into 3. In the same way, this expression can be further written as 3 into 4ab squared plus 1. Do I make sense? All of you get that?
So I've actually solved it in the second method, so I'm taking down the first method again.
Very good. Yes, if you've done it in the second method, very good. Yes, you have realized that you have to take out the common factor. That's very good. Very good. Finished? Yeah. And children? Let's continue. Continue. Sorry? Last one. You finished 2 BC? You finished. Okay. Fine. You tried, not good. Okay. Which one? You finished 2 A, B, C? What about 3 A and B? Finished. Trying which one? C. 2C. Okay. Yeah, please take your answer. Please check if you have not finished completed. Online students 2C, please check your answer. So here also all the four terms have something in common. 2 is common between all the four terms. This expression has four terms and the four terms have 2 in common. So to take out the common factor 2 and then do the grouping. Remember that. Whenever all the terms of the expression have something in common, take out the common factor and then group. So here again in 2C, all the four terms have 2 in common. So take out the common factor, then do the grouping with the terms inside the bracket. Group these two terms, and then you see in the brackets, you have the same expression. So write it once, group these two and put it in another bracket. Yeah. Finished? So here again, you can see multiples 2, 4, 8. Multiples of 2, 2, 4, 8. 3, 6, 12. 2 ones are 2, 2 twos are 4. 2 ones are, 2 twos are, and this is 2 fours are. 3 ones are, 3 twos are, 3 fours are. 2, 4, 8 in the tables of 2. 3, 6, 12 in the tables of 3. You might not get the grouping correctly in the first shot. You may do it in a particular way. The expressions in the bracket may not match, so you will have to do it again, but you will get it. You might need a few attempts, but you will get it. When you make a mistake, mostly the next attempt you will get it correctly, because that mistake will tell you what you should not be doing. So you will get it. At home, when you practice this, you should not see the first step and then complete it. That you can do. If you see how it is grouped, then the next step is easy. You should not see how it is grouped. You should learn. You should see to that you are able to group it without help. Once you have to group, specific terms, the following steps will be easy. When you have 6 terms, which 3 to group is important. So that step, if you see your book and, then continue, there's no use. You should know how to group. That is important. That you should learn to do by yourself. And that will come by practice. The first step பார்த்துட்டு அப்புறம் பண்ணக்கூடாது. இந்த first step book பார்த்து எழுதிட்டு அதுக்கப்புறம் இப்ப நான் பண்ணிட்டு வேணா இதுதான் important. In factorizing by grouping method, the first step is important. How we organize the terms, that is important. Oh yeah, you haven't finished? Lesson 1, we finished the workbook also yesterday. Last class? No? What did we finish from lesson 1? Only PQs and in class we did. In class we did? You're very soft. I can't hear you. We did only PQs. So in class and workbook we have to do. Okay. We'll not go back there. So I'll share the images with you on WhatsApp. Of lesson 1, whatever's remaining in class and workbook, I'll share the images on WhatsApp. You can finish it as homework. Finished? Yeah. Yeah, match quickly. Match. You can see 3 expressions in the first column and some results in the second column. You should match. Match like this and this and this, like this. You should match. Finished? So you've done your workbook. Okay.
Done.
Okay. Yeah. Yeah, you've matched A with 1, 2, or 3. 2. A with 2. Correct. B with 3. And C with 1. Very good. Okay. So these are the correct ones. You have it now? Okay. Matched? Okay. We need to go ahead. So this is again simple. So finish it fast. Take the help of the slide and complete it fast. Yeah, Surya, leave some space there and complete it later. Let me see how you can complete that. Next one. I hope you understand what we're doing. This is your workbook, block 20 workbook. Okay. First question was this: smash the following. 2A we finished. Now we're seeing B. 2B. Yeah. So Shreya, see here. Look at the expression. 1, 2, 3, 4 terms, right? Shreya, 4 terms. Yeah, okay. 4 terms, right? 1, 2. Okay, the separators are the plus and minus signs. Plus, minus, plus. These are the separators. So this is one term, second term, third term, fourth term. Plus and minus are the separators. They separate 2 terms. All right. So now between the first and the second term, look at the first and second term. What's common? 2x plus 3y, right? Yes or no? Yeah. And what is common between the second and the, sorry, the third and the fourth term? The third and the fourth term, x plus 1 is common. Now, what you have to do is, so you have to actually group this one like this and this one like this, right? But since there's a minus here, you cannot just put a bracket. See how the signs change inside the bracket. See here. This one, you can just freely put a bracket. You can see that's what is done here. But when you put a bracket here, what happens? There's a minus, right? There's a minus. So minus into plus is minus. See here. Okay, you're going to insert brackets like this, right? This is what we're doing. When you do that, when you put a bracket here, it doesn't matter because it remains the same. This one is the same as this one. But when you put a bracket here, okay, the sign changes. Because see here, minus into this one is a third term. Minus into plus is minus and the fourth term. Okay, See, if you have minus B minus C, you cannot just put a bracket like this. When you have minus B minus C, when you take out a minus, in the bracket you will have minus B minus into plus is minus C, B plus C. Minus B minus C. Okay, minus B minus C. Now minus in the bracket B, minus into B is minus B, minus into plus is minus C. So when you have minus B minus C, you cannot simply put a bracket like this. You will change the meaning of the expression. So when you want to use a bracket, see, when you take out this minus and if you want to insert a bracket, minus into B, minus into plus minus C. In the same way here, since there's a minus sign, when you insert the bracket like this, see here, bracket, the terms are the same, children. The terms are the same. See this? The terms are the same. Just be careful with the sign, that's all. The sign. Minus into this term. You see it here. Then minus into plus is minus. And this term, you see it here. It's only with that sign, not the term. The term will be the same. So take care of that. The sign here, take care of the sign here. When you insert a bracket, minus into minus is plus. Sorry, minus into plus is minus. Sorry. Minus into plus is minus here. Minus into plus is minus. So the sign we'll have to take care of that. Now, now see here, 2x plus 3y is common. So 2x plus 3y once, and then gather x plus y in another bracket. I told you can write anything first. And here x plus 1, x plus 1. So x plus 1, and then x plus y in the other bracket. All right? All right? That's the first step. Now, after doing this, remove the brackets. We have x plus y into 2x plus 3y minus x plus y into x plus 1. Now, what's common between these two? X plus y is common. X plus y. X plus y, write it once. And then in the bracket, you should write this one minus this one. See here, this is one term. This is another term. They're separated by minus sign. X plus y is common. X plus y. So write it once, x plus y. Then in the bracket, you need to write this one. You need to write this minus, then this one. Yeah. So next step, 2x plus 3y minus x minus 1. Minus x minus 1. I forgot to simplify. So that's equal to x plus y. 2x minus x is x. 2x minus x is x. X plus 3y minus 1. Yeah. Work this 2 times, children. Now, work it once and once again. Yeah. See, if you think, like using the brackets is difficult, or, we can do it like this also. We'll do it together now. See, tell me what's common between the first two terms. 2x. All of you look at the board. Yeah, what's common? Gayatri. Okay. So 2x plus 3y is common, right? Then what comes in the bracket? X plus y. This part is understood, right? Then whatever sign follows, you should write that, correct? Whatever sign follows, minus. Minus, correct? Yeah, write that. Put that sign. Okay. Then what's common? X plus 1. Now you should be careful while writing the sign. Minus x plus 1 is out here. So what should come inside the bracket? No, the first term I'm asking. Correct, you're right. This into what will give you the third term? X into x. That's why I use a bracket, but I think when that looks more complicated, I think. See here, this is the third term. This is the third term. What's common? Between this and this, x plus 1 is common. The sign is minus. Minus x plus 1. Now, this one into what will give you this third term? This one is common outside. Minus, okay, let me just slash out. Wait, 1 second. I think this will be easier for you to understand. See here, this one is out, okay, and this one is also out. So what remains? X? No, that only will come inside the bracket. You have written this minus x plus 1 outside, right? So what will come in place of the third term? X. X here. Then fourth term. See, this is the fourth term. You have written this one outside. You need to write y. But should you write plus y or minus y is the question now. Okay, let's understand like that. Should we write plus y or minus y? Okay. Now let's write minus y. Okay, minus y portal. Suppose minus y. Minus into minus is plus. It'll become plus. It's not, it's minus y. So you should put a plus here. Then only it'll be minus into plus minus y. Minus into plus is minus and y. I want to do this first step again. Come again, tell me what's common. 2x plus 3y is common. Okay, so let's slash out the common. This is common. So what should you write inside the bracket? In the bracket, x plus y. Okay, fine. Then what sign follows the second term? Minus. You should put that only. Now what's common between the third and the fourth term? X plus 1 is common. Write that. Write that x plus 1. X plus 1. Now be careful. X plus 1 into what will give you the third term? What is there? Minus x is there, right? If you put a minus x, what will happen? There's all, okay, minus is also out common. Let me slash out that also. Minus is also common outside. X plus 1 is common. So what remains? X. Put that. Put that. Now x plus 1 is outside. Minus into plus is minus. And that y. All right. Okay. Now what's common between these two terms? X plus y is common. X plus y. X plus y. So like slash it out. Okay. Don't actually slash it. Now so that we understand what to write inside the bracket. Okay. So x plus y is common. So in the bracket, you must write 2x plus 3y, right? Minus x plus 1. Then x plus y. Open the bracket now. Minus x minus 1. X plus y. 2x minus x is x plus 3y minus 1. Yeah, you can take it down like this. Yeah, practice this. Yeah. Done working? It's all about grouping, so I have nothing to say. Finished? See you. See you. Thank you. Hello, what was this? What we finished was block 2, lesson 2, right? Yeah. Okay, the identities, you're already familiar with them. Algebraic identities. What is a plus b the whole square? Very good. A square plus 2ab plus b square. What about a minus b the whole square? A square minus 2ab plus b square. Very good. And what is a square minus b square? Yes. A plus b into a minus b. Correct? A square minus b square is a plus b into a minus b. Online students? Able to recall these identities? Okay. All right. Fine. So what we've been doing so far is factorizing algebraic expressions by the method of grouping. We've been factorizing algebraic expressions so far, and the method used was the method by grouping the terms. So if the expression has 6 terms, we gather 3. We have 3 terms, take out the common factor. So that's what it is. So now this is factorizing using the identities, the algebraic identities. All right. So this also, I have nothing to explain because we have done, in fact, we've completed this chapter earlier. You can help yourself. Just maybe do the first one quickly. So 25s square should be written as, see here, use empty brackets, children. This is like a square plus 2 into a into b plus b square. Use empty brackets, Shriya. Okay, use empty brackets. A square plus 2ab plus b square. All right. Now 25s square. So it will be 5s in the bracket, right? Because 5 square is 25 s square. And then what in the last bracket? 6, 16. So this is a square. This is b square. So what is 2ab? 2 into a is 5s into b is 16. Now check the product. What is 2 into 5? 10. 10 6 is 60. 60 st. And that's what we have here, 60 st. So it's of the form a square plus 2ab plus b square, which is factorized as a plus b the whole square. You must show that this expression is of the form a square plus 2ab plus b square. The given expression has 3 terms. You must present this expression in the form a square plus b square plus 2ab. First, find your a and b. Only then you can write the 2ab term. See, that's what we did. Use empty brackets like this, plus 2 into a into b plus b square. Use empty brackets like this. Fill the first bracket and the last bracket. So 5s here and 60 here. Then the middle term, 2 into 5s into 60. Yeah, so this is like a square plus 2ab plus b square, which is a plus b the whole square, which can be written as a plus b into a plus b. A plus b the whole square is a plus b into a plus b. Yeah, quickly write down. Finished? Yeah. Next one. So these are the square terms here, p square and 81q square. So this is a square plus b square, and this is minus 2ab. A square plus b square minus 2ab is a minus b the whole square. A square plus b square minus, see, you can even interchange the terms, you know. A square minus 2ab plus b square is the same as a square plus b square minus 2ab. It's the same. A square minus 2ab plus b square is the same as a square plus b square minus 2ab. A minus b the whole square. A minus b the whole square. No, we just see here a square plus b square minus 2ab is a minus b the whole square. So use empty brackets, a square plus b square minus 2ab, 2 into a into b. So this will be p, this will be 9q, right? So 2AB will be 2 into P into 9Q. So check this 18PQ. Yeah, 18PQ. So it's of the form A square plus B square minus 2AB, which is A minus B the whole square. Yeah, write down. Light unchuru. வெளியில ஃபேன் போடுங்க, ஃபேன் அனுப்பிச்சிடு. முதல்ல ஃபேன் அனுப்பிச்சிடு. இருட்டா இருக்கு. அங்க ஃபேன் ஓடிட்டு இருக்கா? இந்த லைட் அனுப்பிச்சிடு. Yeah. Yeah. For what value of A finished? For what value of A will P square plus AP plus 25 be a perfect square? Okay. Now, when we say A plus B the whole square, it's a perfect square. A plus B the whole square, it's a perfect square. A minus B the whole square is a perfect square. If A plus B the whole square is a perfect square, that means A square plus 2AB plus B square is also a perfect square. This trinomial is a perfect square. The trinomial, because it has 3 terms. Now this trinomial is a perfect square because this can be written as A plus B the whole square. And this trinomial, A square minus 2AB plus B square. This is a trinomial, 3 terms trinomial. Now this trinomial is a perfect square because it can be written as A minus B the whole square. Okay, now the question is, we are given this trinomial P square plus AP plus 25. Okay, all right. Now P square plus AP plus 25, what should be the value of A so that this one is a perfect square? All right, so now this can take 2 forms. This can be P, this can be like A square. This can be of the form A square plus 2AB plus B square, or it can be A square minus 2AB plus B square, because they're talking about perfect squares. Okay, this is a perfect square. That means this one can be A square plus 2AB plus B square, or A square minus 2AB plus B square. There are 3 terms here, children. Are there 3 terms here? And the question is, what should be the value for A so that this expression is a perfect square? So we have 2 forms of perfect squares. In the case of a trinomial, there are 2 cases when the trinomial can be a perfect square. If we have an expression with 3 terms, so we have a trinomial. There are 2 expressions. We know 2 expressions of trinomials which can be perfect squares, and they are A square plus 2AB plus B square and A square minus 2AB plus B square. Both these trinomials represent perfect squares. So the given expression should either be A square plus 2AB plus B square or A square minus 2AB plus B square. Okay, so That means what is a square? P the whole square. What is b square? 5 the whole square, right? Then what's the middle term? The middle term can be 2 into, it can be plus or minus. It can be plus or minus 2 into a into b, p into 5. So the middle term can be plus or minus 10p, right? The middle term can be plus or minus 10p. Can be plus 10p or minus 10p. So if AP is equal to plus 10p, then A is 10. If AP is equal to minus 10p, then A is minus 10. I'll work it for you. Okay, so the steps will go like this. P squared, listen again, listen. AP plus 25 is equal to P the whole square. Okay. Or let's just yeah. So what in the first bracket? What in the first bracket? Okay. The given trinomial is p squared plus AP plus 25. Now this can be of the form a squared plus or minus 2ab plus b squared. Correct? I put a plus or minus here. Now this can be of the form a squared plus or minus 2ab plus b squared. Correct? Okay, then what in the first bracket? P. The last bracket? 5. Then 2 into a into b will be 2 into p into 5. Correct? So that is p the whole square plus or minus 10p plus 5 the whole square. Okay. Oh, you don't have to even write the step. See, it's okay if you don't write this also. What is the middle term we have then? Compare the middle terms. So AP is equal to plus or minus 10p. So that means AP is equal to 10p or AP is equal to minus 10p. So P will get cancelled on both the sides. So A is equal to 10 or P will get cancelled on both the sides. A is equal to minus 10. So A can be 10 or minus 10. In both the cases, the given expression will be a perfect square. See, this we understand. The presentation is the issue. So we'll do it again. Now tell me, you tell me. P squared plus AP plus 25. All right. Write it as P the whole square plus or minus, because perfect square can be plus 2ab or minus 2ab. So we'll say plus or minus 2 into a into b plus b square, 5 the whole square. So we get p here and 5 here, right? 2 into p into 5, correct? Now compare both the sides. Compare both the sides. Plus ap is equal to plus or minus 2 into p into 5, right? So AP, on comparing both the sides, on comparing both the sides, on comparing both sides, AP is equal to plus or minus 10p. So AP is equal to 10p, A is equal to 10, or AP is equal to minus 10p, P cancels, A is equal to minus 10. So for both these values, it can be a perfect square. Please write down. Finished? Yeah. And yeah. Done writing? Online students?
Yes, ma'am.
Okay. So now this one is, this expression has only two terms. Factorize this expression, which has only two terms. And you can see the minus sign here. So this of the form a square minus b square. So please use empty brackets is equal to a square minus b square. This of the form a square minus b square, where a is y square. You understand why? Y square, the whole square is y to the power 4. And 25 should be written as what in the bracket? 5. Should not write 25 inside the bracket. 5. 5 square is 25. Then only x, just x. Because x, so 5x the whole square means what? 5x into 5x. 5x the whole square means 5x into 5x, which is 25x square. Yeah, so you should present it in the form a the whole square minus b the whole square. Here, a, this is a whole square minus this is b whole square. So how do you factorize it? A square minus b square is a plus b into a minus b. What is a? This is a plus b. This is b plus b into a minus b. What you have written, cover the square, cover the square. Don't take out the square. This is only a. This is a. This is b. Right? This is a square. So if you remove the square, this is only a. Read it without the square. This is b. So y square plus 5x into y square minus 5x. Fast. Finished? Yeah. Yeah, I want to finish the other lesson also. Yeah.
Ma'am, may I be excused for a minute?
Yeah, okay. Done, right? Yeah. So what is this? Something the whole square minus something the whole square, right? So 16 is what? Surya? 4. Because 4 into 4 is 16. 4 into 4 is 16. A square will be A. B square, B. Then this 25, 5 by 4, 2. A square, A. Yeah. So see, this is A square minus this is B. This one is B square. So what is your A? 4AB. What's your B? 5 by 2A. Without the square, what you see is your A. Without the square, what you see is your B. So A square minus B square is A plus B into A minus B. You can see it here, A plus B into A minus B. Yeah, write down fast. Murshkiya. Okay. workbookலயே பண்ணிட்டியா இல்ல? சரி. Finish. Right. Okay. This is the next one. Now see here. Is there anything common between the two terms? Everywhere, whenever you have to factorize an expression, if the terms have something in common, take out the common factor. Now 3s square and 48t square. What's common? What is common between these two terms? 3. 3 or t? 3. 3 is common. Yes, 3 is common. 3 is common. Open a bracket. Chulungo. S square by 49 minus 3 into what is 48? 16. 3 into 16. Then t square. So see, this expression has two terms. This expression has two terms. So there's only one option for you. You can factorize this using the identity a square minus b square, but they don't look like perfect squares. This expression has two terms. If the expression has two terms, we only know one way of factorizing it, and that is using the identity a square minus b square. A square minus b square means the terms must be perfect squares. And this is 3s square and 48t square. 48 is not a perfect square. 3 is not a perfect square. Right? So you have to take out. So in this expression, there is something common between the two terms. You must bring out that common factor. Now, once you bring out 3 as the common factor, now see the terms inside the bracket. S square by 49. 49 is a perfect square. S by 7 the whole square. S by 7 the whole square minus 16 is 4. T square is t. 4t the whole square. Now in the bracket, the terms are perfect squares. Correct? But the expression given, which has two terms, the two terms are not perfect squares. But once you take out the HCF, the common factor, inside the bracket, the terms are perfect squares. Now you can factorize this one using the identity a square minus b square. Hmm. 1, 6. You should find the prime. 41. It's a prime number. Yeah, 41. So you will not get factors earlier. You should directly hit 41. Easy, right, children? Take out the common factor. Then the two terms inside the bracket are perfect squares. So write them as a the whole square minus b the whole square. See, mistake that can be done is s square by 49. இதுதானே bracketல இருக்கு 16t square. அதான் இங்க ஸ்கொயர் இருக்கே. அதனால நம்ம என்ன பண்ணுவோம்? We'll write it as a plus b. s by 49 plus 16t into s by 49 minus 16t. No. You should write it as something the whole square. In the square poradu. This is not enough. It should be something the whole square. So this one should be expressed as a perfect square. And that is s by 7 the whole square. 16t square is 4t the whole square. You must put it in this form. And then now this is a square, a the whole square minus b the whole square, which is a plus b into a minus b. Yeah. Yes, now tell me. Oh, sorry, online children finished?
Yes, ma'am.
Okay. Yeah, Harsha, what's common between these two terms?
Ma'am, 6 is common.
6.
Ma'am, 2.
Numerator?
V and U is common.
U and V, is it?
Yes, ma'am.
Correct. Very good. So U cubed V by 36 minus UV cubed by 64 is equal to what's common in the numerator? UV over what's the HCF of 36 and 64? என்னாச்சு? What's the HCF of 36 and 64? 4. 4. Open a bracket. என்ன வரும்? U square by 9. 9 4s are 36 minus V by 16. 16 4s are 64. So taking out the common factor, not some factor, the highest common factor is very important. UV by 4. UV is common in the numerator and 4 in the denominator. 9 4s are 36, right? And then 4 16 are 64, correct? And then when you multiply UV into U square, you must get this. UV into V square, you must get this. Okay. So is equal to what you've taken out as the HCF, leave that. Nothing will be done with that. That will just come as it is. Now in the bracket, write it as something the whole square minus something the whole square. So U by 3. Yeah, V by 4. So now this will be UV by 4 into, stop, one of you here. Continue. Yes, Shriya. Minus V by 4, then minus V by 4 plus A square minus B square is A plus B into A minus B. A plus B into A minus B. No, this is in the form A square minus B square, right? What is this like? A square minus B square. So the answer should be A plus B into A minus B. This is in the form A square minus B square. So the result is A plus B into A minus B. Right on? So here you must write using identity. Using identity, a square minus b square is equal to a plus b into a minus b. Done? Online students completed this one? Yes, ma'am. All right. Yeah. How do you factorize this? What's common? A to the power 4, x to the power 4. Then minus law of exponents. When bases are same and it's multiplication, we add the powers. See here, how do you multiply this and this? A to the power 4, x to the power 4 into a to the power 4. 4 plus 4, 8. When bases are same and it's multiplication, we add the powers. So 4 plus 4, 8. See, the common factor is a to the power 4, x to the power 4. Open bracket. You need to get a to the power 8. X to the power 4 is common. A to the power 8. We have a to the power 4. So another 4. 4 plus 4 is 8. Minus, to get the second term, what is the second term? What is the second term? A to the power 4, x to the power 8. What is common? A to the power 4. No, what is common? A to the power 4, x to the power 4. Yeah. The second term is a to the power 4, x to the power 8. This one is common. We need to get x to the power 8, but we have x to the power 4. So 4 plus 4 is 8. After taking this common, the first term is this one. This is the first term. This is common. Here we have a to the power 4. We need to get a to the power 8. So 4 plus 4 is 8. So we need to write a to the power 4 inside the bracket. Minus, the second term is this one. The second term is this, of which this is common. And we have x to the power 4 outside, but this is x to the power 8. Another x to the power 4. Right? Okay, so this is the first step. So how do you start? Yeah, write along with me. A to the power 8, x to the power, I think. Yeah. So after doing that, children, this is like a the whole square and this is b the whole square. A plus b into a minus b, and that can be done again because again this is like a square minus b square, so a plus b into a minus b. This is further a square minus x square is further a plus x into a minus x, right? Whatever is taken out common, nothing will be done with that. That just comes out as it is. The HCF, which is outside the bracket, that just comes down in every step. Nothing is done with that. We factorize the expression inside the bracket. So here, which looks like a square minus b square. So present it like that. Show that it's of the form a square minus b square. Then a plus b into a minus b. Again, this is of the form a square minus b square. So this one is a plus b into a minus b. These two as it is. Okay, I'll share these answers. Yeah, we'll just do this one and wind up the session for today. Recall from memory. How do you factorize a trinomial which is not a perfect square? By splitting the middle term. How do we factorize a trinomial which is not a perfect square? With a trinomial, you can see the numerator and denominator, they're trinomials. 1, 2, 3 terms in the numerator. There are 3 terms in the numerator, 3 terms in the denominator. Correct? When the trinomial is a perfect square, then you can factorize it as a plus b the whole square or a minus b the whole square. If the trinomial is of the form a square plus 2ab plus b square, then it is a plus b the whole square. If the trinomial is of the form a square minus 2ab plus b square, then it is a minus b the whole square. But if you have a trinomial which is not a perfect square, then you factorize by splitting the middle term. By splitting the middle term. So what do you have in the numerator? Let's do the numerator. You should actually do it together. But now just to explain, I'm doing the numerator separately. So m squared plus 7m plus 12. This is the numerator. Recall sum product. What is the sum? Huh? No, correct. But what is the sum here? The coefficient of m, right? 7. Sum is 7, correct? What's the product? Product is 12. Now, what are the two numbers that will satisfy the sum and the product? When will you get sum 7 and product 12? Using? Yeah. Okay, then no, this cannot be done in a hurry. Anyway, we have already done this year. I'm saying we've done it. I'll share a short video where I'll be explaining only this, this kind of factorization. Have a look at the video and complete the assignment, which I'll be posting on WhatsApp. So children, it'll be like this. Sum and product. So the numbers are 4 and 3. 4 plus 3 is 7. 4 into 3 is 12. 4 plus 3 is 7 and 4 into 3 is 12. So you'll have to split the middle term. M square plus 4m plus, no, it's completely out of your mind, is it? Forgotten, right? Oh, no, there's no pointer. Okay, fine. No problem, no problem. I'll share the relevant video. Please watch the video and complete the assignment, which I'll be posting on WhatsApp. All right? Yeah. All right, children. So that's it for today's session. Online students can leave the call. Good night.
Thank you.
Thank you. Good night.
Thank you, I'm gonna